So it's going to be easier once we're inside because of the car noise and the airplane noise. But I'm Brian Rayski. This project has been my pet project for the last five years. And it's taken on a life of its own. So I just kind of wanted to share how that's gone now that we're nearing completion and take you through it, kind of show you some of the features, some of the benefits. I'm not going to get too heavy into the numbers. You can do that in an office space sometime. And I just want to get somebody's eyes on it besides you guys who've been working on it. Take the first half. Who's this? This is for the Zoom. This is on me? Okay. So what half are we going to take? Whoever showed up first. Whoever showed, Nando, I know you showed up first.
Resetting.
You don't count. You're nice. Special tracks. Yeah.
Okay, here we go right away. And go now. Rolling.
Mike, don't be looking. So the first thing I want to talk about is how this got built from the ground up, envelope, as we all like to talk about. So it's SIPs panelized construction, but not wood SIPs. It's galvanized steel stud and expanded polystyrene foam. So after checking out a couple of 4 manufacturers all across the nation, this is the one I decided to go with, specifically because of the lack of thermal bridging, right? So that insulation is continuous all the way through the panel and can be manufactured 4 feet by 12 feet by a various number of thicknesses. And being who I am, I wanted to maximize that. So although these are 5.5-inch panels used in the home are 7.5. So R30 continuous, we can all agree on that. So when I first saw these panels, they were butt joint construction, and that didn't sound good to me. But after new ownership came in, they were able to come up with a tongue and groove. And so you can see all these panels are going to be tongue and groove all the way up. They just slip together. Framing and then a couple of extra pieces of metal, 2 feet or so. They've been installed by the framer in a little over 5 weeks. So I was happy with that. It was their first panelized job. They were excited to do it. And we got a good result on site. We got plenty of photos to document it. And the cool thing that you're going to get to see is, because you can't see anything behind the drywall now, is in the mechanical room, because panels were actually used. So, although these panels have been used in the city before, this is the first time that we used the low grade. And that took us about 12 or 13 months to let the city see those calculations, come back with more data. Lateral loads from the soil and everything else. So these are engineered panels. Every single one is engineered to go in a particular place. They can't be mass produced. So there's a lot of basically posts and other headers and things like that have been designed into by the structural engineer and in collaboration with the manufacturer. So, yep, just like this, just turn it on its side, and that's what's going to be above that window, right? More steel, but still all continuous, but connecting to the other side of the frame. But one reason I use this panel manufacturer, Thermosteel, is because their process doesn't change the thicker or thinner you make the panel. It's still 2 frames, and then you just tell them how many inches you want in each one, right? So adding more installation to this assembly doesn't cost any more labor. It just costs material. And so when we think about all the layers that go into making these high performance homes,
So you'll need to use
adding layers means more labor.
Why
and
that
not
way,
just
yeah.
the picture. So that's kind of why we landed on this. Now, starting from the ground foundation, 2-foot footing, and then set these panels in a track and started setting them, moved around, made the whole basement that way.
Camera going up?
Then we came back and did 8-inch granular fill and laid down this 1-inch tubing here
Rolling?
to do the Geo Exchange Loop. So it's not geothermal, right? It's a Geo Exchange Loop, no compressor involved. We're trying to get that natural thrust temperature and press through on the ventilation side. So it's only going to handle the ventilation though, right? Take energy, add energy back in before the ERV kicks on. I'll get to the ERV later. As you can see here, this is not foam board. It's just a vapor barrier and radiant barrier. So I wanted to take advantage of the fact that there's free cooling available to us. And in our climate, the free cooling is larger in quantity than the free heat that we might be able to get, right? Those heat losses. So the reflective barrier is just to radiate heat back in when we put heat into the slab. And it's just a foil barrier with 2 pieces of bubble wrap on it. So I thought that was a great decision in terms of getting energy out, but not ruining comfort because we put the heat back into the slab, doing electrically. So that's the most unique thing in the basement in terms of the panels being used for the foundation, reducing the concrete needed by about 50%, and then not using any actual insulation. That's, I think, less than an R1, right? But reflective barrier, and lets us contact it. So.
And sorry, is the tubing around the foundation or
under slab? Yeah, I think it's about 16 inches in the center.
And 96. Great, terrific. We'll go to
Hey,
96.
It will be connected as a pre-cooling, preheating coil for ventilation. So why don't we just go back and see those
15
panels
Charlie.
and go to my favorite room of the house, the mechanical room. Yeah, so we had to fur out to let for electrical because we're in the city of Chicago and everything's in conduit, right? So, there is benefits to doing conduit, but not for installing. So we did have to, the panel manufacturer wants to tell you to put it inside, but not in this jurisdiction, right? So, but we got to use that cavity for other
Thank you.
things.
That was good. Extra.
So
50 mil, please.
this will be 96.
Yeah. I think we ended up putting it in
Hopefully there's
D3.
extended viewing.
Yes, 93.
Although obstructed, not fully obstructed. Open walls are good for tours.
So Emily will go 96 and ND3.
Okay, so this is
And then 360
mechanical
shutter.
room. First thing you should know once you look in here is that there's no fossil fuel burning appliances, right? This is an all.
He's still on a
home.
P360.
A lot in the city of
She's
Chicago.
asking.
Yeah.
No natural gas has ever been brought to this address.
So key.
So once we started doing the calculations, meaning load calculations for heating and cooling, found out, hey,
Is it worse?
it's
Yeah,
less than
she's
35,000
talking about it.
BTUs even at -10. So why bring natural gas here? We don't need a furnace. There's not a furnace small enough and controllable enough to control the temperatures on 3 levels very well.
There's another reason.
Go ahead.
If you have a hookup, they'll give you a free service coming in. But when you're hooked up, and you don't use anything.
You're still paying.
$82 a month.
I think,
This membership.
yes. I think it was 36 something last time I checked,
Now it's-
but that's $400 a year. So tell me one thing you can do to save your client $400 a year like that, eliminate people's gas. So that's what we decided to do. we started looking for equipment that was better sized for proper zoning. And Mike Schaefer at Mitsubishi Electric helped me out learning this product. It's 3 air handlers through one
Air handler.
branch pump, all to one outdoor heat pump. So cold climate heat pump down to -13, -23, whatever numbers you want to use. And so this is the furnace style unit. Made sense to put it in here. Handles first floor and basement, and then primary bedroom suite is handled by a pancake unit, horizontally facing unit in the attic, and then there's another one facing the other direction with 3 bedrooms up there. So we get 3 great zones in terms of how those spaces are used, like diurnally, right? Not in your bedroom a lot during the day, and this will handle the rest of the house at that time, and then we can go upstairs and get different temperatures and the different sleeping arrangements there for our young kids and in the primary bedroom. So that's the branch box. So this is a 3-port branch box. Each one of these goes to a separate air handler, and this one goes out to the main unit. Serves as a manifold, yep. So that's doing all the controlling. This house originally, like I said, this project took on a life of its own. Started out as a speculative build, but with all the things that happened with the pandemic and everything, the only way to push it forward was for me and my family to commit to moving into it. And so all of a sudden, everything got turned on its head. You know, so one thing that we wanted to do for a spec home is to make sure that people don't have to see this ugly Mitsubishi equipment. So we ducted everything, right? You walk into this house when it's finished, you won't know that it's an all electric. You won't know that it's got a heat pump in it. It'll just feel like a regular house for this neighborhood, right? And so I know this neighborhood well. I've lived in it for 8 years. So that's what I thought the market needed, was to look and feel like a regular conventional home, but perform the way we all think it should perform, right? Low carbon, high indoor air quality, health conscious, right? The fact that all these wires are in conduit required by code, as much as we might disagree with it, it does give us protection from EMS, right? It does give us protection from electrical radiation, like magnetic radiation. So that's a benefit, right? We should talk about it.
And somebody asked before about conduit, how you did that and all these examples.
Yeah, so this is the panels below grade. You get to see it. We furred it out with just furring strips every 16 inches. And then that allowed us to get the conduit in, still have the inspectors look at it and sign off on it, and also reduce labor, right? I think there was a labor saving with just having the carpenter go through with these furring strips and then putting in plumbing and electrical without digging into the panels, or digging into the panels as little as possible. It is easy to deal with EPS, but why do it if you don't have to, right? So I'm standing in front of the ERV, or the conditioning ERV. You know, everybody who makes heating and cooling equipment is putting out ventilators now, for better or for worse. But as a building scientist and an HVAC designer, I need an ERV you can hide a body in. So this is what I found, made down in Bloomington Normal. I'm sorry, not Bloomington Normal, Champaign-Urbana, the other Twin Cities, and by the guys that build Equinox. And it does everything I want it to do. It makes all the smart decisions, right? If we don't know how much air is coming in or going out, or if we set it, but we don't know what the activities are in the home, how can that be the right amount of ventilation? So this is going to have a feedback loop with carbon dioxide, VOCs, and total volatile organic compounds. Oh, I said that already. VOCs, CO2, and particulates, sorry, PM2.5. So that'll be monitoring that and deciding whether to ventilate free cooling or free heating. It'll be deciding to whether to just go into seresic mode for filtration, or just for balancing these 3 levels, right? The attic's always going to be warm, the basement's always going to be cold, and this unit's going to be big enough and smart enough to try and balance that with these 4 risers coming up through here. So these 4 risers are going all the way to the attic, and that'll be able to do a transfer of energy or different temperature air, right? Do that. And last but not least is the heat pump water heater. It's the most efficient, so I got it. It also happens to take up a lot of space. We got it in here, but it's hybrid electric, so I'm going to leave it on efficiency mode and see how my family feels dad of 3 girls, so that might not last too long. So yeah, I think that's about everything in here. No, this is a future basement bathroom. We're trying to get this completed before school started in Chicago, but that did not happen. The Geo is back behind here. It's not worth showing at this point, but just imagine, 470-foot long run all underneath the slab, and it's going to come up, and then there's going to be a coil right here that this fresh air is going to pass through and then down in, and it's going to be getting that free heating or that free cooling from the Geo Exchange Loop. Yep. I needed to get above 10 foot above grade for code. And so since we were going up to the attic anyways, I just took them all the way up. Yeah, one's an intake, one's an exhaust, and the other 2 are return and supply. Yep, those are all insulated once you get into the structure there. But we'll take care of the rest of it once it all comes in. But there's been supply chain issues, so that's why I don't have a coil hanging there. I don't think I need to go into that.
Everyone knows that. But otherwise, that's the only precondition.
That's the only preconditioning.
Yeah.
We might do some post conditioning. We might do some additional dehumidification if this happens. I don't think with a 32, 35,000 BTU load that we're going to need additional dehumidification. And I see when I've worked on projects with smaller loads and smaller usages, smaller exposures, right? Then the humidity becomes an issue because this thing's not going to run very long, right? And so some of the big windows that you see, I think it might balance out, but we have some room to work with. So, also the heat pump in here can only do 5,000 or 6,000 BTUs. So if that's not enough, I'm dumping cold air into my kids' bedrooms. I might want to post condition it, right? I believe in disconnecting the ventilation and the heating and cooling for bedrooms specific, because you spend so much time in them, you want the best air quality there, right? Just like with EMFs, maybe our brains are being affected by Wi-Fi and other technologies, but let's at least not expose ourselves to them while we sleep, while we're trying to recover, right? Like maybe we need these technologies in our lives, but not while we're asleep. So that's kind of the way this has been designed. I'll show you the other technologies upstairs. I guess we can just poke our heads in the back. Poke our heads in the back. It's a 400 amp electric service with a critical load panel there, and a whole home central vac for the health aspects. There's no carpeting in this house because it affects indoor air quality. I thought with that decision it might make sense to go with a whole home central vac with a HEPA filter to go along with it. So yeah, that's the 400 amp service, and then this will be all off. This is the critical load panel, so lights, sump pumps, refrigerators, anything that we've deemed critical if the power does go out is going to go off a future battery. So still working on how that's going to be part of this net zero home. That is, I don't know why they put foam there, honestly. The only foam that you need is right there. So I don't know why they're foam. I will be monitoring. Let's go up and look at the electric panel upstairs. From the heat pump. Oh, you're on the ERV, sorry.
Yeah, there's a little in the serve 2 here. There's actually a little compressor.
Yeah.
So that can do additional conditioning. Yeah, inside of it.
And that's why I call it a serve, a conditioning ERV instead of just an ERV. So this is 5,000 BTUs of work we can do. Here's another 18,000, right? And then this is the peace of mind that all my clients seem to ask about. What happens when this refrigeration system goes down during a polar vortex? Not like, will it be able to keep up? I get that question too, and we can show that it will, but this electric resistance coil is my, let me sleep at night and I can still heat the whole house, right? So I'm just gonna turn it off, right? And then if I don't ever need it, I never need to put it in, but at least I have it, right?
I always say when I talk to people about being a sole source with a cold climate air source heat pump or utilizing the air handler, this is just a little additional piece to put on there. I mean, if we're in a cold climate, why not?
I've just,
put a piece of mine on.
I
If
think,
you're doing the air handler.
Yeah, what is your?
So we rate them down to -13, but that's not a shut off, it's just a rating end. So there is actually no thermal shut off on this system. There's a potential for safety at -18.6, but it doesn't mean blow. So it just, if everything's working functionally, it will continue to blow. Yeah. As you get lower in that point anyway, and that's ambient temperature. We don't know how often it gets to actually -18.6. But the benefit if you're doing an air handler, I mean, putting on the heat is such a simple thing.
for $500, this lets you sleep at night, right? Like, you know, this is gonna be an electric furnace if you need it. Otherwise, you got a, you know, more complicated system.
The only additional labor for putting something like this on this, right, is another haul.
You don't get that if you do an office set.
If you're doing off the set, no. If you're doing off the set, there's no.
Yeah, this is the only unit that'll accept it.
Yeah, the units upstairs, we don't make the kits for, but there's third party. For the pancake style, there's third party.
So if it's
Upstairs.
No.
Yeah, I don't.
So let's go talk about thermal mass. I don't know if I have one. So like I said earlier, we furred out all the interior walls on the panels to allow the electrical and some of the plumbing get in there. And I said, well, what's the other use? Should we just fill that with insulation, another 3/4 of an inch? So I found this product called Energy Blanket, and it's a phase changing thermal mass product. So heat or cooling comes through, and this doesn't resist the way insulation does, it absorbs it. So you might not feel that heat gain or heat loss for some hours, 2 hours, 20 hours, 40 hours, depends on how much heat's coming through, right? But in Chicago, our climate, we've got 10, 15, 20, maybe even 30-degree swings in 48 hours. So I think this is a great addition to, instead of resisting the thermal transfer, but absorbing it and then releasing it later, right? So it also doubles as a reflective barrier, right? So this is facing out on the walls, and also an EMF barrier, right? So anything that's coming through from that cell tower or my neighbor's smart meter should be reflected by this as well. So this was installed heavily in the bedrooms, again, trying to protect us while we sleep, and then in other areas facing the neighbor, the exterior walls in the basement, things like that. So you can come feel this. It's in liquid state right now because it's warmer, but it's a soybean-based material that will go from liquid to solid between the temperatures of 65 and 75 degrees.
Is it stapled onto the front?
Yeah, it just got stapled yeah, so you just staple it here on the top, and then the cells stay in the bearing strip cavity, and then push the drywall against it.
So is that continuous then? Like sheeting, if you will?
It is not continuous. It's just hanging. It's a 12-inch strip hanging in a 16-inch space or 14-inch space.
Put the next one.
This next one goes there, yep. And these are facing out when you install it. So, like that.
And then where would the next vertical one go? Or just there'd be a
Yeah.
space in it.
Yeah, so I mean, they might be continuous horizontally, but not vertical.
And then how long will those last? Change phases infinitely, or you have that yet? Or,
We don't, I mean, I don't personally.
well, yeah,
It's
probably new technology.
newer. I mean, Chase Bank has been installing them in all their locations for a decade, I think. But that's a heavily cooling-based application, so this is kind of, I'll show that later. It only works one.
Can you model the increased mass, effective mass of that too, or like calculate?
So REM rate doesn't work that way. It's not about, 8,760 hours a day with temperature, right? It's just heating degree days multiplied by temperature difference, like that's it. So there's no way to model it in REM rate. We could get it into something that does do 8760 hours, but haven't done that. Not sure if I will. I think it's just going to be something that we test and see how much better than REM rate do we do, right? Because I have a feeling that the serve and the Geo Exchange, right? Serve's going to be making decisions about whether to bring in free cooling or free heating that other ERVs don't. That's not modeled either. Real-time decision making. This is the same thing. This is real-time absorbing and releasing that we can't model using REM rate. So. The other thing was,
Sorry, the only other, what we just had an entry for, are you a 1, 2, or 3 math?
okay.
And then that gives you sort of a bonus based on how much mass you have.
Sure. So the Mitsubishi furnace style unit in the basement did have electric resistance heat, but as Mike mentioned, the units upstairs in the attic don't. So if the unit was to malfunction or need a technician to work on it and there was some downtime, what could we use to give us heat in the bedrooms while the unit was being, while the system? So I found this product. It's basically electric resistance heat mat, right? And the reason I liked it because it is ultra thin, less than a 30. So you can literally put this anywhere. So it's in the bathrooms, it's in the bedroom ceilings for silent heat while we sleep. And this is kind of something that's part of this living laboratory here is just something we're going to try out. We tried it last winter, just put it behind the kids' board, and see how we can keep it on, right? Because my heat furnace go on every time, right? It bangs on, and then am I awake? This is silent heat, so it's something that I'm kind of labeling as something that contribution to comfort, right? So it maxes out at 104 degrees surface temperature. So you just hook it up to a line voltage thermostat and let that thermostat measure the air. And then if it's too cold, it'll come on, right? Oh yeah, yeah. I'm not trying to integrate any other way. I'm just going to let it past this warm surface, right? This warm ceiling, and the air will pick up some of that heat too.
So it's an emergency.
I'm going to use it maybe programmed at night, right? It's going to stay on at night to keep the bedrooms from dropping below 60 something, right? And then if the ERV or something else is on, it has to be on. But it's not paintable, no. Here, you put it behind something. You need at least an R1 on. Drywall. In the bathrooms, it's tile on the floors. On the ceilings, it's drywall. Right, so it's under floor heat for the bathrooms, right? But that thing's something like 17 layers and a 37 of an inch. It's pretty cool technology.
So what are the wires?
No wires. It's all printed. It's all printed circuits.
Resistance.
Here's a wire. Here's a wire. Don't cut. Here's a wire. Here's a wire. And there's 3 wires per 20 inches. I should have plugged this in. Maybe you guys come back in and feel it. And then an all-electric kitchen. So induction cooktop. Nope, living laboratory. I'll have to throw out the aluminum pans, right? We have a second oven over here, but it's a microwave. So we put it over here so we use it less. That's the idea. Oh, I'll send you upstairs. I don't think you need me upstairs unless you want to stick your head in the attic. There is a ladder. If you want to stick your head in the attic and see, Mike, you stick your head in the attic and see those pancake units. Just go straight out. These guys, those are just electrical boxes because we haven't figured out. So the ERV supplies the air handler for first floor and basement. There's so many different rooms, right? They're used in really different ways, right? Kitchen, mudroom, living room, office, bedroom, playroom, whatever, downstairs. So it's kind of hard to monitor what's going on. So instead of trying to, dump it into the air handler, let the air handler deliver it using a cooling duct. And then where do I think it's important? In the bedroom. And that's when it's dedicated. That's when the ERV has its own supply register. What do you mean? It's a vent to hood? Vented to the exterior. So that's the oven vent. This is a vent to hood. It's got a particularly interesting design because there's no filter for the grease. So the fan actually uses centripetal force to send the grease against the side of this box. Exactly. And so you can get more grease removal this way at lower speeds. And so I'm thinking about how much makeup air does the ERV need to handle? Because that's what's going to happen. This is going to turn on, and then through a relay, the serve is going to know, hey, I've got to get rid of 275 CFM.
Making an example of how to give a person balance itself, or it's sort of balance once and it'll.
I think you set this relay to tell it, and then you tell it 275 is what you're supposed to be bringing in when this relay turns on.
So maybe you have to worst case rebalance every 5 years.
Yeah, I mean, I can't imagine if that'll be a problem, but this is multi-speed, so maybe that's the issue.
The reason I was asking is I was looking at the Zender. I think Zender does it internally on.
Based on pressure?
Based on pressure. Yeah.
That makes sense. Right, same thing with the serve.
Yep, basically.
Based on pressure.
What if they serve sensitive to
Some of that.
it's using an
And doesn't always take out that air, so.
The serve?
Yeah.
Right, that's why it has to know. Hey, I'm in research mode, I'm not taking any outside air. Now I need to supply 275 without pulling anything out, right?
Yeah.
Supply only, because that's my exhaust, so I'm still balanced. Yeah. This is my first experience with this. Yeah.
Any special features in the garage?
None until I get solar on it. It's got electric car. I mean, it's got its own 125 amp panel in the garage for the future solar. I mean, I'm not going to have an electrical vehicle in the next, I don't know. So, but for future, it's future proof. I tried to future proof it as much as possible. We designed it 5 years ago.
You mentioned that there, we have panels on the garage.
So if I have only southwest facing panels, which is the long side of the house, I cannot achieve net zero. So what we're waiting for is the calculation. Well, the calculations from Tesla have come back, and we will be net zero if we blanket the entire house wherever Tesla solar panels can go. Correct, because it's not north, it's northeast, around the angle. Yeah, it would be different.
And is it if it's too north, would they, would Tesla recommend not putting in? Because I know there are like,
Depends on your goals, right? Are you trying to achieve a fast payback, or are you trying to achieve net zero, right? You always would put them on the north side. If net zero is your goal, it's just the payback's close to 30 years in some cases, north facing. So it's like, well, 22 and a half years. Well, the warranty runs out at 25, you know, so. But
which way is north is, north is.
45 from the window.
You're on the train track.
Yeah, that's why we got the triple pane windows, not for performance necessarily, but for sound, right? With the overhead noise and the train noise and the car noise.
These are these?
These are weather shield vinyl line. Visions? Yeah, visions. Well, yeah, these are triple pane, low E argon. 0.20.
You happen to know what DC is up there?
No. No STC.
Well, triple and vinyl do well.
I mean, it was designed 5 years ago. Then the next 3 years was, how do we make it go? Who's going to invest in this? To be the speculative build. Then the pandemic hit. Then I couldn't get anybody to build it the way I wanted to build it. And then we decided, let's move forward. I mean, my family's grown in 5 years, so it makes sense now. It didn't in 5 years.
I'd probably use the like.
Oh, yeah. So, can we have another group though? Any questions? Do they want to see the attic? Might as well show them the attic. So, you know, I bought my last conventional home because it didn't have a fireplace, also known as an exhaust fan. And so we wanted this house to not have a fireplace. But once we decided that we were going to move into it, my wife insisted on it. So we have an electric fireplace. It looks nice. It's going to look nice.
Yeah, I was working with this was one of those ones that.
All right, people are sticking their heads up there. Nice.
And then we finally got it.
So you see the 2 units up there?
The flat,
Yeah.
yeah.
One for the primary bedroom and one for the kids' bedrooms.
Right, we were just talking about the bathrooms. After that.
No,
The bathrooms, do they have any supply or are they all the flooring?
they're all flooring.
All flooring. That's what we thought. We didn't see enough work and I can't remember.
Yeah, no supply in the bathroom. You know, it's always uncomfortable in the summers when the bathrooms are so cold. Yeah, condensation dripping off the metal register.
The door, at least in the mountains, I mean, the door being open most of the time, so, you know.
And you're gonna put it into exhaust and pull all that conditioner in there anyway. So.
Did you see a return though in the master one? There was one of the things in the.
Low.
paper, so.
And then an exhaust. Yeah, no, there's no return in the bathroom.
Gotcha.
I don't want to recirculate that.
Right, that's what we were confused. It's like,
Yeah.
oh, there's no return in there.
No. Yeah, we're both shaking our head about the same thing.
There was one of
Oh,
those-
yeah, exhaust vent, yeah.
Exhaust. Makes sense.
Where the-
Single direct exhaust,
Um,
or is it
It's technically an inline fan that serves more than one bathroom with a relay switch. So anytime someone goes into any of the bathrooms that aren't the primary bathroom, then that relay closes and the single exhaust fan exhausts to all of them simultaneously.
Is that the inline fan? Is that what I'm
Yeah,
seeing?
yeah, that's the one thing. It also exhausts, it also has an exhaust in the laundry room to get any heat out of the laundry room. Right, right. Because in Chicago says you can't recirculate air out of a bathroom.
But isn't that what the things in, like low down in the floor, isn't that the?
Out of the bedroom,
Out of the
right?
bedroom, but there was one of those in the bathroom.
That's the supply side.
Ah, okay, yeah, sorry.
Tony, you want to stick your head up in the attic here? I know, so.
I have one of these in my exhaust fan.
Yeah.
They have 2 ducts in each bathroom.
Nice.
So, works pretty good. I don't know about heated bathroom floors though. They take a while to heat up. So I've actually got mine on timer.
That's why, if you want to look at this real quick. These provide heat a lot faster.
Yeah, that's what I mean. Like first thing in the morning, if you walk in here,
Yeah.
no matter how fast you.
Right, that's why this is, though, you turn this on while you get in here and you get out, it's already warm and hot. It is, but it has heat.
Okay.
So it's 2 switches, one for exhaust, one for one upflow fan, one's a downflow fan. Especially with the high ceilings. You're looking at the primary bedroom or radon system?
Yeah, I was gonna say, did you, there wouldn't have been any way.
Say it again?
There wouldn't have been any way to test the radon prior to building it.
Exactly, so put it in and then if you want to test later.
It'd be interesting to shut it down.
Exactly,
See,
because then I can stop running that fan,
oh, yeah,
the radon. fan.
yeah, so our house is, I know it's like radon, it's everywhere, but we're, miles from you,
Right.
we're below 2.
Yeah, sounds good.
Thank you. Very well done.